positive. It's gonna go up. Okay.
But when you calculate it's positive 5.7 something, and then when you calculate A, is like 1.9. So the answer is 2 up the incline.
Okay.
That's number 8. Number 9, 1.5 kilogram. 1.5 kilogram object has a velocity it is accelerated at a constant rate for 5 seconds. After which it has a velocity so the question is, what's the magnitude of the resultant force acting on the object? So there's something at the beginning, it was moving along the y-axis, but in the end the velocity becomes like this. So there is a force acting on the object, and then it will start to move like this. And then at 5 seconds, after 5 seconds, the velocity becomes like this. So for this kind of question, we also need to think along x and y. So along x, at the beginning, what's the velocity?
0.
It's 0. Perfect. And then in the end, it's become 6. And it's 5 seconds. So we can solve the acceleration along x, right? And it's 5 seconds. So along y, at the beginning is 5. And the end is 12. So along y, okay. So here you know along x and you know along y. Oh, you can solve the force along x. Actually, the same thing. The force along x is, right? The mass, ma.
Right.
And it's 1.5 times 8x. 1.5 times 8x. And here is the same thing. Is ay times m 1.5 times ay. So if you, and then right now you found fx, fy, the total force will be right?
So AY is 605. I mean AX, sorry. And 605, right?
6
Minus
over
0.
5.
So it's
Yes.
6.
6 over 5.
So it's 1.5 times 6 over 5.
Yeah.
Okay.
So if you calculate, the answer is 2.8.
Once we do the square
You
root.
calculate here, and then do the square root.
Okay. Let's just do so number 10. It's the last one.
Which one?
The last one, number 10.
Number 10?
Let's just do
Okay.
this last one, and then we can do the rest. We have 8 more problems to do.
We have 8.
We have 8 more.
Yeah.
So we
plus
could plus that one.
1. Like 9.
So we could do it tomorrow, right?
Like when you have time. So tomorrow is fine for me.
What time tomorrow?
I mean,
The same
it's
time?
It's up to you want to do in the night. It's better like in the afternoon or in the morning. So
I'll let you know.
okay.
I will. Okay.
The library closed at 8 o'clock.
Huh?
The library closed at 8 o'clock, we're closed now.
Okay. Okay. I'm sorry. Yeah. So number 10. Let's finish number 10.
Okay, yeah. Let's finish it.
The horizontal surface on which the attention string in that's a type of question. Number 10 and 11 is the same thing. Their acceleration is the same. So the tension in string 1 is 12 Newton. Determine F. Okay. So the F is acting on everything, right? And the common thing is every object here have the same acceleration, is A. They have the same acceleration. So F is all the M, if you add them together, is 5M, right? 2M plus 2M plus 1M times A. We can got this. They tell you this force, the tension 1, this force actually are only taking these two objects, the force of the tension on this string. So only pulling these two objects. So this is 3M A. But they have the same acceleration because they are linked together. If this guy has 2 meter per second square, this guy should have the same thing. So we know from the question the tension here is 12 Newton. So according to this, if you solve this F, from this you can calculate the A, right? And then you solve the F. You will get the answer 20 Newton. The only thing here is you just need to remember is
I don't know how you got that
Excellent.
20. So 3M would be they gave us the mass?
no, they didn't give the mass, but you can cancel out. Here, A, from this you can get A is equal to, right? You move this 3M here. Is equal to 4 over M. From this. Come to the 3, that becomes 4,
Right, okay.
and 8 is, so it's 5M times 4 over M, cancel, 4, 5, it's 20.
Okay. Okay, the answer is 20.
Yeah.